have a lot of clients in Nordics, but we have offices basically throughout Europe. We are growing our offices in Poland, here in Krakow, and as well as in Wrocław, and also the Czech Republic, Ostrava, Finland, and so on. So, and by the way, we are hiring, so obviously, yeah. So we have the booth right to the left of this exit. So come and talk to us. You know, just say hi. You know, if you want to talk to us. Or there's Gavel Mikolajczyk, who is our head of security operations center. So you will be hired immediately by him. Yeah. So, oh, I got a clicker. Sorry. So we did actually with Gavel, we did the last year the introductory talk on the same not the same on the basic concepts of intelligence-driven defense and the ideas that are standing behind it. So today we are going to present you more deep, let's say more deep examples to share our experience, how we are building our use cases, how we are building our framework, also the automation of adversaries, of adversary actions. And there will be a short demo, and let's hope that demo gods are good to us today and everything will work as intended. So, yeah, I would like just to sort of do the introduction of the very intelligence-driven approach, and this definition, the quote of Sergio Caltagirone, which is former Microsoft Threat Intelligence Director. I like it a lot because it's sort of simple, but it's I think it's most true definition of threat intelligence. So the intelligence-driven approach is not new. Let's say as long as humanity had adversaries or attackers in the military, there were always people who were studying the ways how these adversaries operated and studied for improving their defenses. So naturally, this approach evolved to the to the threat intelligence, and like cyber threat intelligence is what we are doing. And there are many important, let's say, concepts and frameworks behind this. Obviously, a kill chain, which most of you are familiar with. The other is also the MITRE attack framework. So Daniil will tell you more about this.
Yep. Thank you, Igor. Hello, everybody again. All right. So, as Igor said, we utilize, or let's say rely on two frameworks. The first one is MITRE Cyber Attack Lifecycle, also known as Cyber Kill Chain, first articulated by Lockheed Martin. I believe, guys, most of you are familiar with that. So, and I just would like to, do a quick recap about this topic, because we already discussed it last time in Code Europe. So it could be divided into two pieces. First piece is pre-compromise stage, and second is post-compromise. And intelligence-driven is about both parts. It's not replacement for a classical approach, but it's, let's say, extension of it. So next framework is attack. Who actually heard about attack? Can you please raise your hand? It's okay. So I will, I will explain it in details. All right. So might suggest first of all, divided kill chain into two parts, and then they detailed it, dividing it into separate tactics and techniques. So, and actually, it's look like that. We have a post-compromise stage, we have pre-compromise stage, and it's called pre-attack and just attack. So, and since our last talk, they have updated it. They created new in a post-compromise stage, joining two tactics from previous one. Excuse me. Boost. I mean, louder, guys. Can you please? Yeah, just increase the beat. 1, 2, 1, 2, 3. 1, 2, 3. Is it better now?
All right. Okay. Now it's better, yeah. So they have added 71 new software entities. They have added 71 new software entries, 18 groups, and most important part is that they have added new tactic to it. And now it's look like that. You have here columns, which are tactics, and separate boxes, there are techniques. And for now, there are up to or even more than 200 techniques. And each technique described in wiki style page. And it includes description of examples, who has used this technique from well-known threat actors, how to mitigate, how to mitigate this specific threat, how to detect it, and just the references of it. So, and as you can see, it's not very detailed. It's very high level, and it's not complete. I mean, you cannot just take it and create detection using these 2 lines of text. It is just impossible. So that's why we actually decided to create our own framework using extended format. So here we are, Theater use case framework. We just, using attack matrix as basic threat model, but we use extended attack matrix. It means that we add our own techniques, our own tactics, increase the, let's say, detailization of it, and each use case is a threat, description of threat from different points of view. For example, triggering conditions, data needed, logging policies, etc. And today I would like to show you a real example from our knowledge base and show how exactly it looks like. All right. So our use case framework is nothing but just the structure in Confluence knowledge base. And all these entities which I've just mentioned, there are just substructures of the big structure. And of course, they include different related articles. Guys, can you please just fix somehow this noise? It's. All right, they will just stand here. Excuse me? No, it's not there. Yeah, it's somewhere there, so probably. All right. So as you can see, that's just a substructure and folders. And I would like to show you one example. And if you remember here, on this slide, we have detailed how they, explain exfiltration over alternative protocol. And in our use case framework, we created our own use case which called exfiltration over DNS, and it's mapped to this technique. And that's the problem of attack matrix. They have different levels of detailization, and they are not always, ideal. So that's why we decided to detail it in more, separated in more pieces. Okay, and here we have a full description of it. Mappings to different frameworks, such as CAR, CAPIC, again, attack. Most important for us is mapping to list of data needed, data we need to collect to, for example, detect this specific threat. Next part is software, which we can use or which attackers can use to trigger these alerts. Next part is alerts related to this threat or to this use case. Logging policies and hardening policies, but for now we will focus on more alert side. Okay. Also, use case itself, use case article includes all analytics related to, or if analytics works, related to this case. So for example, we have conducted the analysis with PCAP, with DNS server logs, and now you can see the part with NetFlow. So it's kind of description how can you detect DNS exfiltration using NetFlow with some diagrams, etc. So, alert. One of the entities which maps to use case, and for this specific use case we have something like, 15 alerts, and this is just one of examples. So here, most important part here is data needed. It has mappings to, again, to our own articles about that, and to detect this specific activity, we need very simple things: list of well-known domains, queries log or DNS transaction log, or analyzed traffic. So if we will click to DNS queries log, we will appear in this article, for example. This is the data needed. Here we have a raw log, example for CM team. Here, and most important thing here is mapping to logging policy, which is just a way to enable DNS query log. So if we will click on it, we will obviously see this logging policy. Nothing, it's not rocket science, we just collected a few lines of text which we need to add to configuration file and then reboot the service, and then we will have this log on DNS log server. So next part of alert is correlation. And here, first and most important thing is high-level detection logic. This logic is system agnostic, so our CM team can implement this logic in each and every CM system. So first thing we do is this high-level detection logic. And last but not least part is triggering. So exactly the way how we can trigger this specific alert. And here we have a list of software and specific commands to execute to trigger this alert. For example, if we will click on Nishank, we will see the article related to Nishank, description of it, and specific, let's say, unit test, which is just a huge one-liner, and unfortunately we cannot see the end of it, but it doesn't matter, just a PowerShell. So, the most important and quality of our use case framework is completeness. We have everything, for example, we are trying to collect everything related to some specific area. For example, if we need to detect some specific threat, we collect in logging policies, we describe in data needed, and we describe in detection logic. So we can just go to our customer and say, all right, you would like to cover this threat, so you need to implement these logging policies, we need to collect this data, and we will implement this detection logic. But of course, detection logic is only on our side, so sorry. And now we more discuss detection side, and Igor will show you more about testing and simulation stuff and automation in this area.
All right. So, yep. 1, 2. Okay. Is it okay? Thanks. So yeah, I want to focus on the specific area, which is kind of triggering conditions. You can call this unit tests. You know, these are the specific like one-liners, bash scripts, shell scripts that are performing either a specific technique using various tools, using the I'm sorry, using the either built-in tools or the specific attack tools or frameworks and so on and so on. So we have this huge knowledge base, and we wanted to build ourselves a capability how we can integrate this in kind of the continuous testing and DevOps environment, because a lot of modern security teams are heavily borrowing concept and ideas from the DevOps. So we have the automated infrastructure provisioning, the configuration management. We use different Ansibles, Vagrants, Terraforms, and we want to build everything on top of it, everything on top of DevOps. So we started to look around, and there were many kind of new and emerging tools around this specific area, which is called nowadays like adversary simulation frameworks. So actually Mitra, who are the authors of Attack Matrix and various other things, released their version, which is called Caldera. It kind of focuses more on the custom remote agent and the visual side of things. There is also the UberMeta, Red Canary, Atomic Red Team. There are actually a lot of frameworks, so we didn't want to write a new one. What we wanted to do is we wanted to take everything we already knew, like everything we had, and started already working with it without too much of a hassle. So we have settled on this UberMeta, and of course we are not saying that you should use only this one, because they are all different, and you should test it probably themselves. So UberMeta was perfect for us because it's, of course, open source. It's written in Python. Everything is better with Python. It's easily scriptable. It has easy readable YAML playbooks, and of course, it's the targets are cross-platform, so it supports Windows, Linux, and Mac OS X, unlike, for example, Caldera, which only supports the Windows targets. So, for example, here is an example of the technique, which is the credential dumpings with built-in Windows tools. So we have here the Mitra attack mappings and the purple actions, which are essentially our unit tests. But the next evolution, the executing only one kind of technique is not boring, but it's not fun. More fun is simulate the whole chains of different techniques, or simulate the specific threat actors, various APT groups, penetration testers, and so on and so on. So we can easily define our scenarios, different phases that we want to run. So we wanted to show you kind of how this concept can be applied in real life. So who knows about the finesse, Fisher, and the hackback attack? Okay, two. Two people, and I know them both. All right. So it was very loud attack back in 2015. The breached company was named Hacking Team, and they got breached like completely. So the emails were leaked, the source code, like everything. And after that, there was this guy, or I don't know, maybe there are many guys, but he called himself Phineas Fisher, and he published a very detailed, very long document on how he performed all these actions. And this document is very valuable for us as a defenders, because it's like a first of a kind, first person documented APT attack from the first person point of view. So we got here everything, tools, techniques used. We actually, this is a slide we already shown, but we showed essentially manual way how we can, you probably don't see anything, right? Yeah. Manual way how you can detect all of these techniques. So today we also wanted to show you automated way how to perform these attacks, and the automated way to detect this. So this is a mapping of this hackback attack by Finesse Fisher to attack matrix. And here's our simulation profile. You probably also don't see anything. Anyway, there were a couple of missing techniques in the meta itself, so we developed kind of additional stuff. Here should be demo. Who is excited? All right. Now I will switch to the and the materials and the pre-recorded demo will be also published on this link, which you just have seen. So give me just 1 second. No, nothing. How it should be done? Okay. Is it like this? No? Okay, for some reason I cannot see this. Ah, all right. Yeah? Can you take this, please? So we got the empty Kibana dashboard, which is our detection and development platform. So everything is running right now on my laptop, and I don't know if you will see it. Okay. All right. So basically we are in the meta folder, which which is this framework that I'm showing. And we are launching our scenario, which is called finesse feature. Yeah, basically you have seen it already on the previous slide. And so what I wanted to do is I want to switch to the Kibana dashboard. And essentially, we have listed is a static widget. We have listed all the techniques here. So all the techniques that are being performed. So in ideal situation, if we have all the data needed, all the login policies applied, we should see the one-to-one mapping match of all the techniques here on the left. This is the red side, and this is our, let's say, threat detection side. It's not very convenient because I don't see what is going on there. On the top, we have, as in attack matrix, we have this kind of line with tactics, so we can see the overview, and also we can see the sort of the timeline and the highlighted things. So the process injection, the new service, which are signs of the privilege escalation. Of course, we see also credential dumping, which is also not great. What we also see here is discovery. So, the typical things performed by finesse feature. Can you take a look at? Can you take a look at over there? Because I don't see anything. All right. So, but judging by it, if I wouldn't know that this is a simulated attack, of course, I would already call my emergency incident response team, because it doesn't look too terribly good to us. So essentially, in the background, Meta performs all the tests. So on the left side is progress, on the right side is the output of the tools, and we should see one more technique, and essentially it will be over. Do we see 9? 1, 2, 3, 4. Yeah. We do. All right, so it should be, the left side and the right side should be identical. And this is essentially the way that we can test, automate, and verify our detections, our completeness of our, let's say, use cases, quality of our data, quality of our login policy, and so on. So this example, is quite good because everything is documented. But essentially, we can take any threat report and or our own report. So all the materials will be on this link. Snap it if you want. So essentially, yeah. All right. Yeah. So, questions? Yep.
Thanks. Interesting presentation. I have a question regarding the first part, your framework. Is it open sourced or it's closed source Tieto framework? I mean the content, your version of Mitre attack framework. Is it publicly available or not?
No. So essentially the content is our intellectual property, but we are sharing some of it of course, with the audience, and most important, the methodology how we are using it. But these things are not easy to populate all the things. So this is our, let's say, advantage over competitors.
Yeah, and we actually first time released this part with full mappings and kind of descriptions, so you can even find their pretty unique colors for DNS, and you can recognize the logic using the names of them, like large domain name, huge byte rates, etc. So.
Any other questions? Don't be shy. Okay.
Hi. My question is pretty simple. You presented a very nice solution for providing alerts, detecting threats. Do you have something similar to automatically, prevent this from happening, or there is always, human interaction required?
Hello, thank you for your question. It's also the simple answer is that this data, this analytics regarding mitigation or prevention is also part of use case, but now we have discussed detection part and test and simulation, but here in a use case you could notice this part with hardening policy, and just below there are hardening mitigation systems and mitigation services, but they're out of scope. So what I can tell you that mitigation systems are filtering technologies like IPSs, new generation firewalls, and services are the system as a service and kind of detection services like we do. So.
Any?
Sorry, so one more follow-up. So technically it is possible, let's say, knowing that you are monitoring a device, to trick it to fire some rules to block this device from working. You tend to stop something, some access, and then someone just wants to disable device.
In theory, yes. Okay.
Thank you for your question. And first of all, it depends on instant response action and instant response automated actions. And it's, again, it's out of scope. But here, the list of alerts you see, they just producing notifications with different fidelity level. Half of them are investigative, and the second half is high fidelity. So actions and all blocking stuff depends on, case by case, and it depends on IR playbook, which is also mentioned here. But for this specific case, it's just escalation. But we have playbooks for automated IR, which is like kind of auto-blocking, auto-enrichment, and stuff like that. So.
Anyone else? Oh, there's a very long distance. Okay.
My question is, I saw the rule and the logic for DNS exfiltration. So the logic was if the size of the queue is bigger than 70 bytes and not in the list of well-known domains. So I wonder if here you rely on some list publicly posted, or do you create yourself list?
All right, sorry, it was my use case, so Igor probably would tell you more about lots of them, but this one was mine. So first of all, I would like to say that there is some special conditions of these alerts for this specific detection logic. For example, if you will just exfiltrate data to your NS server, you can ask for whatever domain. So you can just put here well-known domain like Microsoft, asking your DNS, and this way exfiltrate the data. So it's also mentioned here in a use case analytic, in the use case article itself. But answering your question is, first of all, we rely on our own analytics. And second is that actually there is not so much, well-known services which kind of could be implemented to each and every customer. It's kind of 30 or something. But of course we continuously update this list. It's not just it's actionable data. This framework is actionable, and we continuously improve it. So, and here you see the example of alert and use case customer agnostic. For each of our customers, we produce, let's say, customer-specific use cases and customer-specific alerts for their infrastructure. Because most of our customers are in Nordics, in Scandinavia, and they have their own specific. And we have to, fine-tune it.
There was a question in the back. Okay. Dun, 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 dun.
My question is about the track name, really. So it says practical intelligence driven.
Yes.
Are we talking only about, let's say, human intelligence, or machine learning, or artificial intelligence here as well? Something which we can use to speed up the whole process which you described?
So the question about how we can use machine learning. Yeah, it's a hard topic on using machine learning. We don't use it currently because I think it's more important to focus on doing the good basics right. Machine learning can come afterwards, but we don't see right now the good, let's say, security use case for it. But in perspective, yeah, we'll use it.
But talking about source of intelligence, we utilize mostly social media intelligence, open source intelligence, and of course specific threat intelligence feeds from our partners, which are just threat intelligence, how it's generally called. So everything. But I can say that most valuable intelligence we do by ourselves. That's the thing, because you cannot just simply rely on someone's intelligence. And yeah, we always have to check if it's true or if it's working or not.
All right. If there are no more questions, thank you everybody, and have a good rest of conference. Thanks.